Okay, let's give you guys some more practice. So here, find dy by dx of this. Okay, so press pause and have a go. Okay, so to do this here, differentiate both sides. That will then give you this. Well, visualize it as this. So when you differentiate log of a bubble, it will be 1 over the bubble, and then you've got to times by the differential of the bubble itself, which in this case will be 3 plus 8x. Okay, so this here would be 3x plus 4. Well, whatever. Differentiate this here, it will then give you this thing here. Okay, so so now it's just a matter of tidying up. So this gets multiplied to the top, giving you this. So dy by dx equals this. Okay, next one here. Okay, so find dy by dx of this. Okay, so press pause and have a go. Okay, so whenever you log something, well, this here, you can take it out here. Okay, so that will then give you this. So now if you differentiate it with respect to x, this here is just a constant. Okay, so this here is this here changes. This here is just a constant. So when you differentiate it with respect to x, it will then give you this. So this here is just a constant. So differentiating this will give you this. Okay, and then oh yeah, sorry, this should be, hang on, this should be dy by dx here. I should, yeah. So from here, differentiate it, it will then give you this. Okay, so here dy by dx here equals this. Okay, so because top times top, bottom times bottom, that gives you this. Okay, next one here. So y equals this thing here. Find dy by dx of this. Press pause and have a go. So whenever you have log of x over y, you can always consider it as being log of x take away log of y. Okay, that will then give you this, and then when you differentiate this, it will then just give you this, because this here is just a constant. It's just a number that doesn't change. So so when you differentiate this, it's just you differentiating this. Well, dy by dx gives you this. Remember that this is just a constant. Okay, this one here. Okay, so find dy by dx of this. So press pause and have a go. Okay, so visualize this as being y equals a bubble to the power of 3. So when you differentiate this, it will be dy by dx equals 3 bubble squared, and then you've got to times the differential of the bubble itself. Okay, so hang on. So when you do that, it would, well, differentiate it, it would be 3, and then this thing squared, and then you've got to times the differential of the bubble, which would be this. Okay, so now it's just a matter of you tidying this up. This here gets multiplied to the top, giving you this. Okay, and yeah, if you're unsure about this, get a graph plotter, plot this graph, and then get a graph plotter and plot this graph here. Well, turn this into a y equals this. So you've got one graph saying y equals this thing here. You've got another graph saying y equals this thing here. So when you plot on a graph, it looks like this. You see the red line here was our original function. The blue line here is our derivative, and you can so hang on. So originally, hang on, let me clear this. So originally you were given this here. When you differentiate it, it gives you this, and you can use a graph plotter to roughly check. So so the red line here was our original line here. This is our derivative, and looking at this here, look at it in terms of the red line now. It's going uphill. It's going uphill. So the gradient should be positive. Okay, it should be positive. So right here, looking at the red line, the gradient here is 0. Now looking at the blue line, it is dead on 0. And then looking at this here, looking at the red line, you can see it's climbing up. It's in the positive realm. It's going up. It has a positive gradient. So here, looking at the blue line, you can see that it's going up. Okay.